Welcome to all. In this session, we are going to discuss the linear accelerator. Linear accelerator is a device which accelerates charged particles along a straight line path. The working principle of this linear accelerator is when an oscillating electric field is applied across the electrodes joined in series, the charged particles or ions when passed through them are accelerated. If the frequency of the applied field is in resonance with the motion of the particles. So when you look at the construction of this linear accelerator, so the linear accelerator consists of series of coaxial metallic cylinders called electrodes of successively increasing length arranged within the tube. See here, these are the electrodes E1, E2, E3, E4, E5, so on are called electrodes, and the axis of all these electrodes are same, and the length of each electrode keep on increases. And the alternate electrodes are connected to two terminals of radio frequency oscillator. See alternate electrodes. This is one, this E1, E3, E5, and similarly E2, E4, E6. That means add electrodes are connected to one terminal of RF oscillator. It's like E1, E3, E5 are connected to one terminal of radio frequency oscillator, and even electrodes are connected to other terminal of radio frequency oscillators. So when you look at the working of this linear accelerator, the positive ions produced at S, the positive ions are produced at this S are allowed to pass through an aperture A and move along the axis of series of electrodes. The radio frequency oscillator voltage is applied the number of times so that the ions are accelerated along a straight line. The ions are accelerated towards the electrode E1, and after entering this electrode they move with a constant velocity. The ions are further accelerated towards E2 by applying the potential between E1 and E2. By applying the potential between E1 and E2, we can accelerate the electron towards E2. Thereby it gains the energy QV, where Q is the charge, V is the accelerating potential of the RF voltage, and the velocity of the ion on reaching the tube V1 is V1. So V1 is the velocity of the ion on reaching the tube V1 is given by half m V1 square is equal to Q into V. Therefore V1 is equal to square root of 2QV divided by m. Similarly, when the ion emerges from the second tube U2 into the gap between E2 and E3, they gain an additional amount of energy QV, so that their energy becomes 2QV. Therefore, the velocity V2 of the ion on reaching the tube U2 is square root of 2 into 2QV divided by m, or square root of 2V1. So, when you look back the diagram, here, when the ion reaches the electrode between E2 and E3, the velocity V2 is equal to square root of 2 times of 2QV divided by m. Similarly, when the ions reaches the electrode between E2 and E3 and E4, the velocity V3 is equal to square root of 3 times of 2QV divided by m. Similarly, when an ion reaches the electrode between E3 and E4, its velocity V4 is equal, its velocity becomes square root of E4 into 2EV divided by m. So this is the velocity V3 of the ion reaching the tube V2. That means in between E3 and E4 is square root of 3 into 2QV divided by m, that's equal to, this is 3, actually this is 3, square root of 3V1, this is must be 3. And similarly, when the velocity Vn of the ion on reaching the tube En, velocity Vn of the ion on reaching the tube En is Vn is equal to square root of n times of 2QV divided by m, or root n into V1. The time taken by the ion to traverse through the tube must be equal to half the time period of RF accelerating voltage. If Vn is the velocity of the ions, Then the time of passes through the nth cylinder of length Ln is given by T is equal to Ln divided by Vn, or that's equal to T by 2, or that's equal to reciprocal of T is equal to mu. The time period is the reciprocal of the frequency of the oscillating electric field. Therefore, Ln is equal to Vn. So from this you will get Ln is equal to Vn divided by 2 mu, or 2 mu. If you substitute the Vn value, you will get to 2nq V divided by m. And we know the relation between the frequency and the wavelength, mu is equal to c by lambda. Therefore, if you substitute it, you will get Ln is equal to lambda divided by 2c square root of 2n q v divided by m. Thank you.